If you want to learn about Unity networking, then stick around. Was that good enough? Was my intro okay? Oh, damn it, let's just get started.
Let's get right into it. We'll start out by making a floor and then 2 walls. And collectively, I'm going to call these units a court, kind of like a dodgeball court. So I just make an empty object and name it court. Next, add 3 sprites that are squares. And I'll call one of them floor. I'll call the other one left wall and the other one right wall. And the floor, I'll just stretch it out so that the scale is bigger in the X, and I'll make it 50, just like this. Get the left wall and move it over. And I'll make the scale on this one to be 10 on the Y-axis. And repeat the same thing for the right wall. Next, I'll make a player, and I'm gonna make a 2D capsule in this case, and I'm just gonna call it player. And on the player, I'll add a rigid body and a capsule collider. And on the floor, left wall and right wall, go ahead and add box colliders, just like this. And we'll go ahead and run it, and so far so good. Go to the player and add a component, and we're gonna add a new script to it. We'll call it player movement script. And go ahead and open up that script and edit it. Add a tag to the floor so we can check to see if the player is grounded. Do that by just adding a new tag, and I will call it ground. Save it, and then make sure that you select it as the tag. And we'll go ahead and make this movement script right here. And all we have is just some basic movement with jumping. We have a grounding check, and we're using a spacebar to jump, and we're using the movement keys to move. And you can see the script like this. Let's go ahead and run it. And when we run it and move, we'll see that our player topples over. So what we want to do is just lock the rotation on the Z axis, and we can do that right here, getting the rigid body and freezing the Z rotation. And now when we run it, our player should just move around without falling over, and we can jump. Next, we want to go ahead and open up the package manager. Do a search in the Unity registry and look for netcode for game objects and install that. Open up the package manager again and get Peril Sync, which is shown right here. What you want to do is just hit the plus sign and install something from a get URL. And the get URL is shown right here. And we just add this thing and it will install it. And what this package is, it is a package that makes testing game programming easier when we have network play. What it does, it makes a copy of our project for us so that we can open it into another instance of Unity and try it out. Once it is installed, we can see this menu appear up at the top. All right, so the first thing we want to do is turn our player into a prefab like this. So now we have a player prefab, and you can just delete this instance of it in your hierarchy because we won't need it. Okay, next we want to make a network manager. So we're going to make an empty object. We'll call it network manager. We want to add a component to the network manager, and we want to add a network manager component. So we have an object in the hierarchy called network manager, and we want to add a network manager component to it. There's a couple properties that we do need to set over here in the inspector. We'll need to set some properties over here. So underneath the network manager, you need to select a transport, and we only have one option to pick, and this is the latest one. It's called Unity Transport, so choose that one. Over here in the network manager, you notice that there is a player prefab, and this network manager is designed for multiplayer games, making the assumption that every player is probably going to have some kind of player object or sprite object. So we would want to drag our player object into here, or just select it using the dot there. Now there are some games that do not have player objects, such as maybe playing a head-to-head word scramble game or tic-tac-toe or cards or something like that. So we want to have a player prefab in here if each player does have some sort of object that they're going to move around the screen. Open up your player movement script again. And the first thing we want to do is make this inherit from network behavior instead of mono behavior. So what we need to do is include the proper library, and it's called unity.netcode, like that. And once we have that, we should see it autocomplete for network behavior. There's a couple new methods available to us that we're going to need to override. The easiest way to override in C#, in my opinion, is just to start typing the word override and then do a space, and then you get a list of all of the methods that you're allowed to override. The one that we want is on network spawn, which is right here. So we see this guy right here, and we can save this. Next, we're going to want to select the player prefab, and right now it's asking me if I want to add a network object. I do, but I'm going to manually add it just to show you this. And what we want to do is just add a component to our player prefab, and the component is called network object, and we see it right here. Once we have a network object attached to this player prefab, the network manager will make sense of it right here, okay, when we have this player prefab. So we can run this right now. And over in the network manager, you're going to have to expand this in the hierarchy. It says don't destroy on load. Select the network manager underneath it and click start host. And at this point, we should see our player move around. Now we'll do a little explanation of what these buttons mean. So let me stop this and start it again, and I'll show you what these buttons mean. We have start host, start server, and start client. Start client will connect to a server and it will spawn a player. Start server is simply for a server to sit somewhere on a network and serve the game. Start host will start the server and start a client both. And we can also use the host whenever we want to have a player acting as the server as well. So I will start the host, and you can see the player appear. And the reason it appears is because we have a player object with a network object tied into the network manager. So at this point, we want to be able to work on our project in two different windows. So this is where we come in and start using parallel sync. So we can see the parallel sync menu up at the top. What we want to do is go to the clone manager. And what the clone manager will do is make a copy of this entire project. So it will copy everything and put it in a temporary spot. And it will also sync all the changes I make in this project and copy it to the other project. So we'll do create new clone, and this will take a little while to finish. And once it finishes, we can see where it makes it. It made it right here for me, demo clone 0. So make sure you look for that up at the top. And what you can do, you can just click open it in new editor, and it will launch another instance of Unity. And we can see that we're able to open up the cloned copy. Now we can see that they have both opened up. On the left, I have my original one. On the right, I have my cloned one. So I will start both of them up. I'll start the one on the left. I'll start the one on the right. One of these is going to have to be the host, and then the other one can be the client. So expand this thing that says don't destroy on load in the hierarchy, click network manager. And under the under here, click start host, and we'll see this guy spawn. He can move around, he can jump. On the one on the right, do the same thing, except we're going to click client. Now we can see that we have spawned a player in each window. When I go over to the left, I can move both players. When I go on the right, I can move both players. So the way this works is both of these systems both of these clients are running the player movement script. And there are two instances of a player object. So we can see the player here, right? We can see the player here in the hierarchy. Then on the other cloned one, we see the player object right here. We see a player object here. So each of these can control both players, and that's not what we want. What we can do, we can programmatically check to see who owns what player, and we'll do that next. Let's start by opening up the player movement script again. In here, we can get a variable to check to see if we are the owner. So there's a couple possibilities we can do with this. We can simply say if we are not the owner, right? I'm sorry, it's is owner. So let's think about this. We can do something here. Now, what this is doing is checking to see if the player that spawned is owned by the player who is running the script. So when we run this, once again, we have a player object shown in each of these windows. So when we do this one at a time, it'll make sense. So this guy's going to start the host. So right now, the guy on the left owns this player that I'm moving over here. Now, when the player on the right spawns his client over here, right, what happens? The player on the right owns this one on the right over here. Now, they both have a copy, a remote copy of the player objects, but the person on the left owns this one, and then the person on the right owns this one, right? So we do not want the player on the left to control this particular player because he does not own it. So what we do is check to see if we own it, and if we own it, then we're going to be allowed to control it. So on the left, we'll start the host. We'll move him over a little bit, and on the right, we'll start the client. And now on the right, I can move the one on the right, which is good. And on the left, I can only move the one on the left. Now, of course, the problem is these movements are not synced up. Okay, so we have to send the movement of our player from one computer to the other computer. Once we start talking about player control and movement, we have to look at the possibilities. We can have a client-controlled network message, or we can have a server-controlled network message. And of course, a client-controlled network message is going to be simpler. It's going to have a little bit better response time. However, it is more subject to hacking. And when we pass things through a centralized server, we can have some logic on there to check and make sure that nobody is cheating and that the movements and logic are valid. So to keep things organized, we want to make a separate script just for the network movement. So let's make another script, and we will call it player network script. Down here, I'll rename it player network script. Let's open that one up. And the first thing we're going to want to do is make sure that we are subclassing from network behavior. And to do that, we have to use the proper using, and it's unity.netcode. So we could simply send up the transform pretty easily, but I'm going to show you how you can pick and choose what you want to send up. This is a more manual way to do it, but it's the way that most people are going to implement it. So first of all, we need to decide which of the parameters we're going to send. So since this is a 2D game, I can move right and left, and I can move up and down, but I really don't have any movement in the Z direction. Secondly, I lock the rotation, so it does not make sense for us to send that. So we typically do not want to send more information that is needed. So for us, we just need to send the position for now, which is an X and Y value, right? Right, so we want our performance to be good. We want to save on network. We want to save on network data that is sent across. So we don't want to send things like rotation data. It's not necessary. All right, so when we send data across a network using netcode, we need to use variable values. Okay, so generally we need to think about sending very primitive values such as integers, floats, doubles, character, byte, right? The primitives are going to make sense for us. We do not want to send reference variables. So an example of a reference variable would be something like an object, right? So we don't want to send a person object or a house object. We need to kind of define them in terms of very primitive value variables, right? And we don't even want to send a string up because that is an object. So we do have fixed strings up here, which we'll talk about. So since we can't send a reference variable, we need to send value variables, and the way we can pack these up is into something called a structure. All right, so we want to make a struct. So what we're going to do is make a struct. I'm going to call it player network data, like this. Whoops. And a struct is from C actually, and it's just a data container, right? So it's kind of like a class without any methods in it, but we are able to send these across the network if we serialize them. Okay, so when we want to put the fields in, we just need floats for X and Y. So we'll do X and we'll do Y. Now this would work, but we can encapsulate this. Right, so we could leave it public like this, but instead we're going to encapsulate it and make a getter setter for this. So they do give us the ability to do that. So what I'm going to do is make this a little bit fancier, and I'm going to make a vector2 called position, right? So I can just grab the position in one swoop here, and I'll make a getter for this, and I'll make a setter. And the setter is just going to set X and Y. And for any of these getters and setters, we always have a field called value. And then if you use the dot, we can get any of the fields, okay, like that. Okay, so would it work just doing public float X and Y? Yes, it would do that, but we're going to make it a little bit nicer internally so we can just get a position value back for this. Okay, now, one of the things that has to happen in order to send this, the only data we have is just X and Y. That's it. That's the only thing we have. This is just kind of a fancy way to get X and Y as a vector 2, right? So we don't have to get the X and get the Y and create a vector 2 all the time. So we do need to make this serializable. And that means that it can convert it into a raw string and send it over the network. Okay, so to do that, what we want to do is make this structure serializable, and we can use the interface network serializable. So anything with a capital I in front of it is an interface. And then of course right away it's complaining because we did not implement serializable. So you could just go ahead and implement it like that if you want, and it'll stub it out for you. Okay, so that's fine, and you just need to fill this thing in here. Okay, so what we need to do is do this. We need to say, okay, let's take this serializer and let's serialize each value. So all you have to do is for every value you have up here, you need to just add it down here. So we're going to pass in ref x, and then we're going to do the same thing and do ref y. All right, so this part, like I said, isn't absolutely needed. If we don't do that, you would definitely have to make these public, right? But I'm going to keep it the way we have it, and you'll see why in a second. All right, so what we're going to do, we're going to make this movement completely client authoritative. So whatever the client says its position is, we're going to just kind of trust and send it off. So here's what we want to do. Let's go down to the update right here. And this is our plan. If we are the owner, we are going to send our position if we're the owner. If we're not the owner, and this is basically my character on someone else's machine, we're going to read the position from the network. So you have to understand that this script is going to be tied to my player. Okay, so my player might be on 10 different games if we have 10 players. And what's going to happen is one of us is going to run this one. This is going to be me running this code right here. And then here, read the position. 9 others are essentially going to read. 9 others are going to attempt to read the position. Okay, so you have to think of this as the object, right? So what we'll do this. We'll say if I am the owner. So we get this is owner, right? What do we want to do? We want to send my position. Okay, so what we have to do is make a variable that is going to allow us to send this network state. So we have to hop back to the top here. Let's make a variable that's going to do that. So we can make a private read-only variable. Yeah, okay, I'm going to make this called a network variable, okay, right here. And we can send any kind of data we want as long as it is a serialized container of value variables. Okay, so do not stick objects and strings inside one of these. So we want to send one of these across the network. Okay, I'm going to call this variable network state. Okay, and let me just go ahead and new it up right here. If I make it read only, I would have to instantiate it right here. Okay, so I'll new it up right here, and we will put in a new network variable, right, of this type, right? And we do have some constructor parameters here. So we have this write permission parameter, and we can basically have some choices. We can have a write position. We have a network variable write permission dot owner or server. Okay, so we're going to choose owner for that one. Okay, so this is the network variable that has to contain all the data that I need to send. So all the data I need to send is my X and Y position right now. So down here, we're going to say if we are the owner. If we are the owner, we're going to set the network state value to be basically a new instance of network data. So I'm going to new one of these up, player network data, right? And inside here, I need to have X and Y, right? So this is kind of like a little inline constructor thing. And what I'm going to do, I could set X and Y manually if they were public, but they're not. So instead, we have this like little fancy way of wrapping up X and Y into this thing called a position, right? So what I'm going to do, I'm going to say position equals transform dot position. So it's my current transform position. And let me put a semicolon there so it auto completes like that. Whoops, we don't put a semicolon. We would put commas between any lines of code that we want to have in here, right? So I could certainly write this numerous times. I don't need to, but I'm just doing this to show you the syntax, right? Okay. All right. So again, you know, this is just kind of nice. If these were public like this, I could simply say x equals, 123.4, something like that. Okay. And notice that we separate any lines of code with a comma. All right, in this initializer here. Okay, but I'm gonna leave it the way I had it. Okay, so now we have our network data defined. Okay, we define how to serialize it. We make a network state variable. So this is where all the magic happens, and it takes care of all the network communication for us. So if we're the owner, we're going to just go ahead and send where we are currently at. So our sprite on everybody else's machine is going to be able to get it. Now, if someone else views me, so this is basically another player viewing my sprite right here. What we're going to do, we're going to transform. All right, so we're saying, all right, we're going to put the sprite of myself being equal to what we just sent up. So we need to read the network position. So we're going to do a vector. Let's do this. Let me just do it like this first. We're going to do NetworkState dot value dot position. And this saves us a little time rather than grabbing the X, grabbing the Y, making a vector 2, right? Anytime we want to refer to the position. So we just grab it like that, okay? So we'll save this and we will try it out. All right, so I have both of these running. So one of these will have to be the client and one will have to be the server. The left is going to be, a host actually. And the one on the right, here, let me move this over. The one on the right is going to be the client. So there he spawns, and now we don't see anything happen. So we will fix this. So don't forget to attach the script to your player. I don't have the player network script in the player object here, so we have to just drag it in or add it as a component, just like this. Okay. Now let's go over to this one and just make sure that it looks in sync. And we can see that the script is on that one. All right, so let's go ahead and run both of these. So we will start the host on this one and move this out of the way a little bit. Start the client on this one. And we can see that we have two of these in sync. I did put a debug logging message in there. So I'm moving the one on the right here, right? But it is syncing on the left. So this is the second player. And if I come over here, I can see this one. So it's actually logging the other player. And we can see that right here, right? So when another player views my sprite, it's logging it. And I can just get rid of that. One thing you will find, it's a little bit annoying to go in, find these buttons every time. So I've been just kind of keeping this selected in my hierarchy. But if you move around, of course, those buttons disappear out of this small section here. So what I do is add a script to add those buttons onto the UI. So what you can do is make a user interface, make a C# script, and you can call them network buttons or network button script. Open that up, and what we want to do, you can leave this how it is, inheriting from mono behavior. You don't need start or update. You can just add this function right here. And what it does is defines a square to put some buttons down. And what it's doing is putting the host, server, and client buttons down. Okay, and we can see it's getting the singleton from the network manager and whatever, don't even put that. Okay, and we do need to attach this script somewhere. So I'm going to attach that script to the network manager right here. So I can just grab the network button script and drag it over to here. All right, so we can run this after we have the button script attached to the network manager. And you can see that we now have 3 buttons, host, server, and client. Of course, we do it over here on the other one. I'll make the one on the left the host, and I will make the one on the right. So that keeps us from having to dig through here to find these buttons right there. And here we have these 2 in sync. So you'll notice it's pretty smooth. That's because I am on the same computer in the same network. So you would want to test your games on a system that is not a single computer. And what you'll see is it could lag a little bit as I move this. So you'll notice on the right, this is pretty smooth running on the right here. But on the left, it's just a little bit choppy. It looks a little bit choppy or blurry because it's kind of jumping a little bit. Doesn't look quite as smooth as the one on the right. And what we can do is deal with the fact that we are sending this over the LAN. Instead of snapping the player at every point, we can interpolate instead. So we'll look at that next. open up the player network script. Right here, when we have another player viewing the movement from a remote player, we can smooth this up a little bit by doing this. We can still use a transform.position, but what we're going to do is just do an interpolation, and we can call a helper function called smooth damp. And we'll have to make a variable called velocity, and it's basically given back to us in case we want to use it. And then we have a value that we can set for the interpolation speed, the interpolation time. So we'll make a variable called interpolation time. And I'll just set it to 0.1 to begin. Oops. Velocity should be up here as a member variable. And we pass in velocity by reference, and we get interpolation, and we pass in interpolation time also. And now we can run both of these again, and we'll make the one on the left the host, we'll make the one on the right the client. And now when we move back and forth, we see that it is smoother, but ever so slightly laggier, right? Because we are pretty much filtering out that jittery movement. So you can see when I stop it on the left, the one on the right seems to go for just a little bit longer. And those are going to be values and settings that you need to decide for your own game. Next, we want to look at something where we have some server authoritative logic. So the way this is going to work, the client is going to request to do something, and then the server is essentially going to decide if that logic makes sense, and if it does, it's going to relay it. So what we're going to do, we're going to make the player have the ability to throw a ball. So the first thing we'll do, we'll make a ball object. So I'll go ahead and make a sprite that is just a circle. So here's our circle. I'll call it ball. We'll make it a prefab so we can make many instances of it. So I'll just get rid of this one for now. It's up in the hierarchy. And with the ball, we'll go ahead and add a rigid body so it has some physics to it. And we'll add a collider. So in this case, we would want a circle collider. We're going to want this to be a network object. So we're going to have to pass around data around with the ball around the network. So we will add a network object to this ball. Now that we have a ball object, we can make a script that allows the player to throw a ball. So I will make a script called player throw script. Put it right here. So here we have player throw script. We want to attach it to the player prefab. So I'll just drag it in. Now you can see we have several scripts for this player, right? We have the throw script, network script, movement script. So let's go ahead and open up the throw script. So we'll start with the easy stuff first. We'll start with the button. I'm going to use P just because it's on the right side of the computer, right side of the keyboard. So in the update, we'll go ahead and check to see if they press the P button. So here's the script to do that. And to support this script, I'm just going to keep a Boolean. And for this, I'm going to have a Boolean to see if the fire button was pressed. So if it was pressed right here, what we need to do is make a request to throw the ball. Okay. And this time we're going to send this up to the server, basically saying, server, I would like to throw the ball. And then the server will decide if it's going to allow it. So we are going to use something called remote procedure calls. Okay, so this is remote procedure call, and it's abbreviated RPC. And we're going to have two types. The first type is server RPC. And what this is server code that runs on the server but is triggered by the client. So the client requests a server RPC. And then the opposite is going to be client RPC. And this one is client code that runs on the client, and it is triggered by the server. Okay, so it's going to look like this. The client is going to request to throw ball. It's going to make its way to the server, and then the server is going to decide if that's allowed. Okay, if it is allowed, then the server is going to contact every single client like that. The first part of it we have is a server RPC, right? Because the client makes the request. It sends the request to the server. If the server agrees that it is a valid move, valid logic, valid action, it will then pass that on and relay it to the clients using a client RPC. I can put that over here like this. So understand that this throw script is going to be running everywhere. It's going to be running on all the clients, and it's going to be running on the server. So here's what we're going to do. We're going to do this. We're going to make a function called request throw ball server RPC. There is a rule, and you need to pay attention because there is a rule that the name of the function for a server RPC must end with server RPC. So the method name can be anything you want as long as it ends in server RPC. And there's a similar rule for the client. The client can have any method name down here, right? As long as it ends with client RPC. So notice I have this thing called request throw ball server RPC. Okay, we are going to pass in the point that the ball should be spawned at and the direction it should be thrown. So we're going to say vector3 spawn point, and then we're going to have the direction it should be thrown. Okay. Secondly, we're going to add this little decoration up here. That's not really a decoration, but okay. And we're going to have this server RPC. So we're going to have server RPC in brackets, and it's coming up as, let's see, I don't like it. I'm sorry. It should be lowercase pc. Server RPC is like that. Okay. And what we're going to do, this is sent. Let's see. We're going to do another one down here. We're going to call this one with client RPC. Okay. We're going to have void request fire client. I'm sorry. How about not fire? How about throw ball client RPC? Okay. And we'll pass around the same data as this one. Okay. So to be clear, let me do this. This is triggered by the client. Okay. So this is the client requesting to throw a ball. Okay. Down here, it's going to call this code down here, and this code is run on the server. Okay. Okay. The one down here is called, let's see, request here. Now here we would have logic to check if it's valid, check if it makes sense, right? So right here, we're just going to kind of skip that, and we're going to simply say, okay, let's just make the assumption that it's always good for now, and we're going to make a helper function called, we're going to make a helper function called throw ball, and we didn't write it yet. So we'll pass the spawn point, and we'll pass the direction. So I need to make this helper function called throw ball, and here's the helper function throw ball. I am passing in the spawn point in the X direction. I'm looking to see if I'm moving to the left or right, and what I'm doing is just either throwing the ball to the right if I'm moving to the right, throwing it left if I'm moving to the left. So the point in which I spawn it is going to be a little bit to the right if I'm throwing to the right, or a little bit to the left, so that the ball does not collide with myself as I throw it. So I could get rid of this to demonstrate, but I'll show you that later. And then we need to instantiate one of those balls that we created. So we do need to create that ball prefab. So we'll do that. So here's the ball prefab. It's a game object. We'll hook that up in the inspector. I'll serialize it so we can access it. And then one more thing we need is just the speed in which we want to throw the ball. So I'm going to make a variable and I'll just set it to be 15 for now. And it looks like I have this one in here twice. Didn't mean to do that. And we have, here we go. Now we have the correct name here. And then we also have to decorate this correctly. Oops, I did that. Never mind. Okay, so assuming the server decides this logic is valid. So remember, I am the server running this. All right, so here is our two functions, request throwball server RPC and request throwball client RPC. So let's go through the logic here, right? So here the user is going to press the button to throw the ball. We'll notice I do have a direction there, and that's just to decide on the direction that I'm throwing the ball, right? So I need to go ahead and consider the direction I'm moving, right? So it'll throw it either to the right or to the left. All right, so a client has every right to make a request, and then the server is going to decide if it's going to be sent or not, right? So right here I have request throwball server RPC. So it comes down and runs this code, and we don't have anything in here yet. Okay, so this is essentially a call to the server, okay? But the server code lives in the same file, right? So this is the server code right here, okay? And so if we agree, right, we can actually have some logic, right? We can say, check the logic. Is this player really allowed to throw, right? We'll just make the assumption yes. So we'll make a call here, and we'll just pretty much immediately call this function down here, right? So we'll do this. So request throw ball, all right? The server says, yeah, go ahead. You're allowed to throw the ball, right? So let's pass in these parameters. So all that's happening is it's relaying, right? So here's the request from the client. Here's the server deciding. And then if the server allows it, he will go ahead and run this here. If not, the server's not going to make the request. So the server makes the request, comes down here. Let me get rid of that. That's not a correct comment. Okay. So we can see here that this code will run on the client, right? This makes a request from the server to the client, triggered by the server, and then we actually run throw ball. Okay. So throw ball is shown down here. So basically we just went in a loop to make this happen, right? Client made a request, server decided if it's okay, the server's going to contact all the clients, right? And then basically it's going to call throw ball on all of these clients. So it just kind of relays the message back and forth. Okay, so one thing I forgot to do is make sure that only the owner can call this. Only the owner can move the player or attempt to throw a ball. So what I do in this case is simply return. And what we have to do here also is make sure that you inherit from network behavior. We have to add the ball prefab right here. So we will add that like that. Okay, let's run through the code. Inside the update, we check for this key being pressed, which means we're going to throw a ball. We figure out where we're at, and we'll call that the ball spawn point. And then we're going to request to throw the ball. If we're facing to the right, this will be positive. If we're facing to the left, this will be negative. The ball spawn point is simply the location. So we pass those two things to the server. Okay, so that goes right down here. The server gets this, right? So This code is run on the server, but it's called from the client, right? So I am the server running this and a debug message, and we'll look for that. And it would check the logic and make a decision. If it makes sense, then it's going to request throw ball client RPC, and that would run on every single client. And it would be run by my sprite object on everybody's client PC, or everybody's client, right? And right here we see I'm the client. And so it essentially goes back and forth. So it goes from the client right here, me controlling my character, pressing the button to throw a ball. The request goes to the server. The server makes a decision. If it agrees with it, then we put this out. If not, then we would not end up making a request to the client. Makes a request, and then once it gets relayed, then the client actually will throw the ball. Okay. Don't forget to have inside your player a ball prefab right there. So let's run this and see what it does. So we'll run it over here, and we will run it on this one as well. Okay, we'll run this. The one on the left will be the host, and we'll keep an eye on the debug messages as well. Okay, so we'll run the host and we'll run the client. And I'm controlling the host over here on the left. And we can see that happen. I'll jump over this guy, throw a ball over there. Oops. Okay. And they are reasonably in sync. We will see some issues here in a second. Okay, run this and throw the ball. We see that the one on the right never says I'm the server. That's because this one over here is acting as the host, which is the volunteer to run the server and be a client as well. So that's why you don't see the message I am the server on the one on the right. So the one on the left is a client and a server. Now, we do have basic network synchronization going on. However, there is a few pain points. We can see that if we make it crazy enough, we can get this thing out of sync a little bit, and we can see that here, right? The screens don't look exactly the same, right? And that happens to be really with the little minute differences in the way the physics are rendered on both systems, right? It could be a few pixels off whenever it actually throws the ball or something like that. So we could periodically sync the position of the ball, right? But we can address more of that later.